I'm going to go over the part 2 from our unit 7, where we have done a lot of different things with matrices. We're going to start off with some operations like addition, subtraction, multiplication, then move into finding those determinants and finding inverse matrices, all leading up to kind of the most challenging type of question, where I ask you to solve a system of linear equations using a matrix equation. So again, as we discussed in class, everything's kind of building to that last thing. So that'll be the focus when I, am grading everything. If you aren't able to do that, it'll be hard to pass. All right, so let's start with the first one. It says B plus A. Personally, I like to rewrite the correct order in terms of they're saying B plus A. Now, I will tell you that because it is addition, it actually does not matter if you would like to do A plus B here, because addition is commutative, which means the order doesn't matter. But I like to go ahead and do this because what I've noticed is when it's subtraction, students have a better chance of getting it correct. If they recognize that subtraction, you do need to make sure that you rewrite so it's in the same order. All right. So when you're doing addition or subtraction, all I'm doing is adding or subtracting the numbers that are in the same location. So like quickly, if I show you an example here, I'm going to be adding 2 plus 4 to get 6 for that first one. Then I have -2 and 5 to give a +3 for the next number. So you just keep going in that same idea. There's 4, there's -5. And that's going to give me -1. So I think you see the pattern at this point. 1 plus -1 is 0. -1 plus 0 is -1. 3 plus -3 is 0. -1 plus -3 is -4. And finally, 0 plus -4 is -4. So this right here is what we call the answer matrix. You'll notice it has the same dimensions as the other two matrices. If you don't have the same dimensions, then you are unable to add or subtract matrices. Let's do a subtraction. Now, subtraction, in this case, it is in that order of A minus B. So I am going to just subtract the things that are in the same spot. So like 0 minus 5 is going to give me -5. All right, but again, if this had said B minus A, I would be rewriting these matrices so that the order is correct. Then we have 5 minus a -1. Be careful here, right? 5 minus a -1 is actually going to be 5 plus 1, which is 6. So don't forget to just be careful as you're doing these subtractions. -3 minus 0 is going to be -3. I'll keep going. 2 minus 1 is 1. 5 minus 0 is 5. -4 minus 5 is -9. All right, so that's how you do addition and subtraction. Let's do some multiplication. Now, when we did this in class, you'll see here the same thing. We're always going to have a 2 by 2 matrix multiplied by a 2 by 1 matrix. I taught you guys that if the inside numbers are the same, then it is possible to multiply these matrices, and the numbers at the beginning and the end give you the dimensions of your answer matrix. So 2 rows, 1 column. All right. Now, I'm going to show my work here. Right? You don't need to do this on the test, but by doing it, you'll give yourself a chance to get some partial credit, where I multiply the rows of the first matrix times the columns of the second. In this case, there's just 1 column. So I have 1 times 4 plus, follow the arrows, 5 times -3. Go to the next row, 2 times 4 plus -1 times -3. Whatever that work is, that's going to give my answers for my solution here with multiplication. So that's 4 plus a -15. 4 plus a -15 is -11. Then we have 8 plus 3. 8 plus 3 is +11. All right, so that's how you multiply matrices. Let's do another one. Same thing here. We're multiplying the rows of the first one times the column of the second one to give us a 2 by 2 matrix. Let's show our work. I'm going to multiply -1 times -2 plus 3 times -3. That will give me one answer. And then I'm going to multiply -3 times -2 plus -4 times -3. All of that will give me the second answer. So that's a +2 plus a -9, which is a -7. This is 6 plus 12, which is 18. So that's how you multiply matrices. Okay, at that point, we moved to determinants. To find the determinants of these matrices, we're going to multiply the diagonals and subtract them. And you always want to start with this first diagonal. So I'm going to have 5 times 6 minus negative 6 times negative 2. Just be careful with this. It's always subtraction, even though you'll see in this case, I'm going to end up subtracting a positive. Sometimes you're going to subtract a negative, which is addition, but always write subtraction. Notice that we had a symbol here that's a negative. That is not taking the place of my subtraction, right? I have the subtraction and I have the negative sign in front. So just be careful that we're setting it up correctly. That's 30 minus 12, which is going to be 18. That is the determinant of that matrix. Let's try this one. We are going to multiply negative 2 times negative 4 minus negative 2 times negative 4. That's going to be 8 minus 8, which is 0. So you can get 0 for a determinant of a matrix. And the last one here for the determinant is going to be negative 4 times 3 minus negative 3 times positive 1. So that's going to be negative 12 minus a negative 3. You could rewrite that. Subtracting a negative 3 is really actually addition. So negative 12 plus 3 is going to be negative 9. All right, so that's how you find the determinants of these matrices. Okay, so now that we went over how to find the determinant of a matrix, we were ready to find the inverse matrix of these different matrices. So the first thing you do with this is you find the determinant of matrix A, which is going to be 4 times 5 minus 7 times 2. So that's going to be 20 minus 14, which is 6. Then to set up the inverse, you're going to do 1 over that value, in this case 6, times, and this is where you have to think switch ops, right? This is important to think switch ops. The first diagonal switch places, so 4 and 5 switch places to give you 5 and 4, and the second diagonal become the opposite sign, so negative 7 and negative 2. To write the answer, you take the numbers that are in that matrix that you just did the switch ops to and divide them by the determinant. So if you want to, as you write it, you can reduce. So we get 5/6. I'll go ahead and not reduce right now, so you can see kind of the setup to put them all over the determinant. But I am going to do one more step for the two fractions here that can reduce. Right, I can reduce negative 2/6 to negative 1/3 and 4/6 to 2/3. All right, so that's how you find the inverse matrix. Let's do another one. So the determinant of matrix A is going to be negative 3 times 3 minus negative 5 times 2. So that's going to be negative 9 minus a negative 10. Kind of like we did on a one previously, when you have that subtracting a negative, that's actually addition. So negative 9 plus 10 is a positive 1. So the inverse matrix, we're going to do 1 over, and notice the value of the determinant was 1. If the value of determinant is 1, when I take all these numbers after I do the switch ops and divide them by 1, you're going to see that the values are not going to change, right? That only happens when your determinant is a positive 1. So switching places gives me a positive 3, negative 3. And the second diagonal become the opposite sign, so negative 2 and positive 5. Again, if you want to write the step where you divide them all by 1, you can, but dividing all of those numbers by 1 is going to give you the same thing. So my inverse matrix is 3, negative 2, 5, and negative 3. Let's do one more practicing the inverse. So the determinant of A is going to be 2 times negative 3 minus negative 2 times positive 3. That's going to be negative 6 minus a negative 6, which is actually going to be 0. And then you guys learned that we stop here and write that there is no inverse matrix because ultimately, as you've seen in the previous two questions, I have to do the switch ops and then take those new numbers and divide them by the determinant. Dividing by 0 is not possible. So if you get 0 for the determinant, you're going to write there is no inverse matrix. So that could possibly happen as well. Okay, so we did all that practice to get us ready for the most challenging questions, which is to solve a system of equations using the inverse matrix. So we did this actually in class today. So I'm going to first write down what is called my matrix equation. So pull down the coefficients in front of your variables, bring the signs with it, times a variable matrix, that's going to be x and y, and then equal to my constant matrix. These are the numbers that are after the equal sign. So -1 and +5. Now from there, we're going to do a bunch of work to find the inverse matrix to this coefficient matrix. All right, so kind of basically doing the same thing we just did the last 3 questions. So let's find the determinant here, which is going to be 1 times 9 minus -6 times -2. That's 9 minus 12, which is -3. So finding the inverse to this matrix, I'm going to do 1 over that -3 times, this is where I'm going to do the switch ops part. 1 and 9 switch places, and the -6 and the -2 become the opposite signs, so they're both going to become positive. Go ahead and take all these numbers and divide them by that -3. So I have 9 over -3, 6 over -3, and 2 over -3, and finally 1 over -3. I can go ahead and reduce some of those. You don't have to do this, but that's -3, that's -2, that's -2/3, and -1/3. All right, so I'm going to use this matrix, which is the inverse of the coefficient matrix, to multiply both sides of this equation by that. So what I do is I actually write down that matrix right here. So -3, -2, -2/3, and -1/3. Then I'm going to copy down that entire left side of the equation, which is 1, -2, -6, 9, and then copy down the xy. And on the right-hand side of the equation, I'm also going to put that inverse matrix in front of the constant matrix. All right, and then times my -1, 5. Okay, so you can see that it kind of basically you copy down the first thing you did, but in front of each side, you're going to put that inverse matrix. Okay, now from there, I showed you guys that the essentially after I recorded today's lesson, I showed you what happens on the left side. That if you basically go from left to right and multiply everything out, you end up just getting x and y, right? I told you guys that you end up getting what is called an identity matrix. So 1, 0, 0, 1. And if you multiply that by x and y, you're left with just x and y. You don't need to show all that work, but I wanted to make sure that you saw that. So that way you knew why. You can kind of just ignore the left side now and focus on the right. So let's focus on the right. I'm going to multiply the rows of that matrix by this column. All right, so let me show my work here. Go ahead and just do it here. All right, so I'm going to multiply -3 times -1 plus -2 times +5. Go to the next row. -2/3 times -1 plus -1/3 times 5. Whatever that is, when I use the calculator, you can use it if you need to, it's going to give me my 2 answers or my ordered pair for the solution to this linear system. So the first one is a +3 plus a -10, which is going to be -7. And the next one is going to be, let's show you the work here, +2/3 minus 5/3. Right, 2/3 minus 5/3 is actually -3/3, which reduces to -1. So my solution here is -7, comma -1. All right, and that's the process for solving a system using the inverse matrix. All right, so now that I've done that, let's do one more. All right, and then we'll be finished with this review. All right, so remember the first step is to write down the matrix equation. So I have 8, -5, -9, and 6 times x and y equals -2 and +3. Let's find the determinant of that coefficient matrix, which is going to be 8 times 6 minus -5 times -9. That's 48 minus 45, which is going to be a +3. To find the inverse, I'm going to do 1 over that determinant value of 3 times, and I'm going to do the switch ops. So 6 and 8, or 8 and 6 are going to switch places to be 6 and 8. And then negative 5 and negative 9 will become opposites, so 5 and positive 9. Go ahead and put all those numbers over the determinant of 3, so 6 over 3, 5 over 3, 9 over 3, and 8 over 3. And you can reduce a couple if you'd like. 6 over 3 is 2. 5 thirds I'm going to leave alone. 9 thirds is 3. And 8 thirds, we'll leave that alone. So now I'm going to write down that inverse matrix in front of both sides of the equation. So 2, 5 thirds, 3, and 8 thirds. So writing down my original matrix equation. And then don't forget to leave room on the right side to write down that inverse matrix as well. That's kind of the key thing here, is kind of making sure you have the setup down. I think what I'll find out is some students know how to do all the matrix operations, but if they don't get the setup right, they may end up doing the actual wrong multiplication here. So I have x and y on the left side, showing my work to multiply this row, these rows of that matrix times the columns of the second one. So that's going to be 2 times negative 2 plus 2 times negative 2 plus 5 thirds. There we go. Times 3. And then the next row is going to be 3 times negative 2 plus 8 thirds times 3. Doing the math there, and again, at this point, you can just type it in the calculator. I'm going to do the math right now. So that's going to be negative 4. 5 thirds times 3 is going to end up being just 5. So negative 4 plus 5 is going to give me a 1. That's going to be negative 6. 8 thirds times 3 is just going to give me 8. So negative 6 plus 8 gives me a positive 2. So my solution is 1, 2. All right, guys, that's it. That's all the questions that you're going to be asked to do on the test. So make sure to go over this, and good luck.